All right. So this is our kind of our warm up after our 5.3 journal. The Jones family is having a family reunion at a park. Can you help figure out who brought what and how much they spent? So Grandma Jones was in charge of bringing paper plates and utensils. She bought 3 packages of paper plates for $5.19 and 2 boxes of plastic silverware. She spent a total of $12.09 on plates and silverware. If P represents the cost of a pack of paper plates and S the cost for a box of plastic silverware, we need to write 2 equations using P and S to describe her purchases. Well, first of all, she bought 3 packages of paper plates, so 3P, and she spent a total of $5.19. We also know that she bought 3 packages of paper plates and 2 boxes of silverware for a total of $12.09. So those are our 2 equations. Which price is easier to find? Well, the cost for 1 package of plates is easiest because 3 packs cost $5.19. So if I wanted to figure out the price, I could just take $5.19 and divide it by 3, and I figure out that a cost for 1 package of plates is $1.73. So $1.73 per pack of plates. So now that we've found the price of one item, can we find the price of the other item? Well, sure we can. If Grandma spent a total of $12.09, and we subtract the $5.19 that she spent on the paper plates, that leaves us with $6.90 left over. What did she spend that $6.90 on? Well, that's the cost of 2 packages of silverware. So divide both sides by 2, and I see that she spent $3.45 per box of silverware. Now, we didn't even use equations because we knew the value of one of them. We wrote the equations, but we didn't have to solve it using the system. Let's look at this next example. Uncle Craig was in charge of bringing chips and salsa. A bag of chips cost $2.25 and a jar of salsa cost $3.50. Uncle Craig spent a total of $41 on both items. He bought 3 times as many bags of chips as jars of salsas. If B represents the number of bags of chips and J is the number of jars of salsa, write an equation involving B and J that represents the total cost of his purchase. Well, he spent $2.25 per bag of chips plus $3.50 per jar of salsa for a total of $41. We also know that the value of B is related to J. How? Well, it says that he bought 3 times the number. Let me see. This is how I want to write this. I'm going to erase that. Sorry, guys. So the number of bags of chips is 3 times the number of jars of salsa. So what does that really mean? That just means that the number of bags of chips equals 3 times the number of jars of salsa. So those are our 2 equations. This is my first equation, and this is my second equation. So now I need to solve to figure out how many bags of chips he brought. Well, I'm going to take this value of B, the expression 3J, and substitute it in there. and solve. So 2.25 B, but I'm replacing B with a 3J, plus 3.50 J equals $41. Well, 2.25 times 3 is 7.75. So 7.75 J plus 3.5 J equals 41. 7.75 and 3.5 is 10.25. J equals 41. I'm going to stop for a second. This is 6.75. 2 times 3 is 6, so this is 6.75. Sorry about that. There I have 10.25. Divide both sides by 10.25. And I find out that J equals 4. He bought 4 jars of salsa. So how many bags of chips did he buy? Well, B equals 3 times 4, which means B equals 12. So he bought 12 bags of chips and 4 jars of salsa. So let's do some kind of quick notes and talk about the main idea. So the main idea with substitution is that substitution is used when one variable is already isolated and I mean you have something like x equals or y equals. You've already got an expression written like x equals y plus 3. So x is already isolated, or the equation can be rewritten to easily isolate a variable. Substitution is supposed to be quick, right? It's not supposed to require a whole lot of manipulation. If you think about example 5 from your journal, example 5 was the example where we had x plus, I think, 3y equals 11. So we were able to get x by itself pretty quickly by subtracting 3y from both sides. All right, let's finish up these last 2 examples. Magdalena is a chef at a breakfast cafe. She needs 4 eggs to make a quiche and 6 eggs to make a batch of crepes. She has a total of 48 eggs. So write an equation. Well, let's see. Let's define our variables. So I'm going to let Q represent the number of quiche. And I'm going to let C represent the number of batches of crepes. All right, so let's see. I need 4 eggs for every quiche, and I need 6 eggs for every batch of crepes, and I have a total of 48 eggs. So you can graph this into Desmos. And you can pick out any ordered pairs that lie along the line. So I picked out the ordered pair 3 quiche and 6 batches of crepes. So that's the ordered pair 3, 6. I also picked out the ordered pair 6 quiche and 4 batches of crepes. So that's the ordered pair 6, 4. So again, any ordered pair on the line. You could have picked the ordered pair 12-0, 12 quiche and no crepes. Or you could have picked the ordered pair 0-8, 0 quiche and 8 batches of crepes. Any ordered pair that lies along that line. If she makes 7 more quiche than batches of crepes, meaning that the number of quiche she makes is 7 more than the number of batches of crepes she makes. Determine how many quiche she made and how many batches of crepes. So we have 2 equations. We have 4Q plus 6C equals 48, and Q equals 7 plus C. So I'm going to take the expression 7 plus C and substitute it into Q in this top equation. So 4 times 7 plus C plus 6C equals 48. Well, then I need to distribute. So 28 plus 4C plus 6C equals 48. Combine like terms. 28 plus 10C equals 48. I'm going to subtract 28 from both sides, and that gives me 10C equals 20. Divide both sides by 2. Divide both sides by 10, and I find out that the number of batches of crepes that she makes is 2. Well, if she makes 2 batches of crepes, how many quiche does she make? Well, 7 plus 2 is 9. So 2 batches of crepes and 9 quiche. All right. Example number 2, you are going to do by yourself. Example number 2 is part of your homework. You're going to do this by yourself. I'll check this tomorrow and make sure that you have it completed. I want you to look at Z and see that Z is represented by the expression 2W plus 1. So you're going to replace the Z in the first equation with 2W plus 1. Then you're going to have to distribute. Example number 3, Brock bought 4 candy bars and 2 packs of gum at a gas station and spent $9.80. So if G represents gum and C represents candy bars, 4C plus 2G equals $9.80. That's my first equation. 2 packs of gum cost the same as 3 candy bars. So the cost for 2 packs of gum equals the same as 3 candy bars. So I'm going to help you out on this one. I'm going to get the cost for 1 pack of gum all by itself. I'm going to do that dividing by 2. So 1 package of gum equals 3 halves times the cost of a candy bar. So I'm going to substitute 3 halves C in for G right here. So 4C plus 2 times 3 halves C equals $9.80. 4C plus, 2 times 3 halves is just 3. 3C equals $9.80. 7C equals $9.80. Divide both sides by 7. C equals $1.40. So now we're going to take that $1.40, the cost of a candy bar, and plug that into 2G equals 3C and solve for a pack of gum. So 2 times the cost of a pack of gum equals 3 times the cost of 1 candy bar. 2 times the cost of a pack of gum equals $4.20. Divide both sides by 2, which means the cost for a pack of gum is $2.10. So a candy bar costs $1.40, and a pack of gum costs $2.10. Number 2 is yours.